Hello, everyone. This is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, Streamlined Deployment Approaches to Improve DAS ROI, presented by Viavi Solutions. Our presenter today is Kashif Hussain, Wireless Solution Marketing Manager at Viavi Solutions. At this time, I'd like to pass the presentation over to Kashif.
Thank you, Kyle. Good morning, good afternoon to all the folks joining the webinar. Thank you for joining. Today we will be discussing streamlined deployment approaches to improve DAS ROI, basically return on investment. So I will walk you through the agenda of the items that we will be discussing. We will start with head nets. What head nets are, how do they work, in harmony with the rest of the network, and how macro cells, small cells, DAS, Wi-Fi, everything works together. So we will discuss at a very high level about what head nets are and why do we need all of that, right? Then we will go into our distributed antenna system. We'll talk about the challenges and some of the streamlined approaches that we identify as ways to improve your time to basically deploy and optimize DAS networks. At the end, we will take the question and answers. So going into the next slide, first of all, let's discuss why headnets are important. I think we are all hearing for a long time that the data is growing, and we can see that through every research that is coming out, that the amount of data that is growing is now in exabytes, which is 10 to the power 18 bytes. And as you can see the trend from 2010 to 2020 on the chart, basically on the left top corner, as you can see, it has grown from somewhere between 20 exabytes and what is expected by 2020, somewhere around 350, close to 350 exabytes. And also you can see the share of the network component, or the type of the network, I would say, from a cell site perspective, that will be taking that share. So you can see in the orange you have the macro networks, which will continue to grow, but as you can see, their growth is relatively smaller. However, small cells will continue to grow at a much significant rate, so would be the carrier Wi-Fi. Also, DAS will continue to grow. There are some challenges with DAS, and especially the cost and the effort it takes to deploy a DAS and what have you. So the growth is slow, but it is there, and it will be significant actually. On this scale, it may look like a smaller proportion, but it's quite significant. Now, what is driving all this is all the applications, as shown on the right-hand side. Like, there are tons of applications coming out day in, day out, video, Facebook, what have you, streaming application, music. Now, where is this data growing? So one of the key things that we need to understand, it's not about just driving on the highways where you need coverage and all that stuff, right? So it's more than that. It's now mostly in building. So if you look at where users are and where they are downloading the data, and when we are talking about data, we are just not talking about the wireless network anymore. It's about how all these different type of networks, like Wi-Fi, you have your Wi-Fi network, you have a small cell network, you have basically the DAS network, they're all working together. Now, residential is taking a significant part of the data where people are downloading and watching movies on Hulu or Netflix and things like that. Then there is the industrial component where there's a huge amount of data as well. Then urban population, where urban areas are. Rural and business. So still, residential takes the most of the data. On the right-hand corner, I've tried to define, there are different definitions in the industry that people have given of what they call as Wi-Fi or DAS or femto, or different type of networks are defined. And it may change, and I see, but in general, there are a few things that line up. For example, when we talk about how do I define that network will be a macro cell, a micro cell, a metro cell, usually it is related to the number of subscribers, the coverage it offers, and also the power transmitted. For example, a macro cell, which is much more significant, as you already know, like 43 dBm, and the coverage can be in miles, whereas a Wi-Fi network or a femtocell network can be much smaller. It can be a single office or home office, which like in milliwatts of power transmitted, and like square feet of coverage we are talking about. So this varies, and how all these different technologies have to work together, that's what the basic definition of headnets. Even in 3GPP, there are standards that are, standards are already defined, and things are actually I would say, have started to work harmoniously to get headnets, basically a head start in my mind. So I'll go to the next slide. Now, when you talk about headnets, right? So just like I said, so conventional, which we call it the macro cells, primarily have been deployed significantly. The trend has come down a little. It's still growing though. Most of the interest was in the last few years have been on the remote macro side. There is a significant growth on the remote macro. Why is that? Because with the advancement of the technologies and the remote radios being more stable, the technology is there where the failure rate is much less compared to, like, I would say, 10, 15 years ago. So now we see a lot of remote radios out there. And what you get out of it is the additional coverage that you can offer, especially on the reverse link, where the 3 dB of additional loss because of the coax cable is almost eliminated using a fiber. So there is a CPRI link now in between that has been implemented, that's been used now very successfully. Going down the list, you have DAS and you have small cells, right? So DAS is also growing, but there are some challenges with DAS, which we will talk about in the next section. And then the small cells. The small cells are growing significantly, and if the coverage requirement and the capacity requirements have to be met, then there is no choice but to have these kind of different cell sites deployed. Now, small cells can be, like we discussed, right? It can be Wi-Fi, it can be femto, or even a regular metro or a microcell. The way they are connected may be different. Some may require if you think about it, a convergence server, what have you, just like in the case of a femtocell. Some may have a dependency on the end users, a wireless or Ethernet network, how they connect back to the core. And some may be just like a BTS hotel concept, like in a big office building or what have you, where downstairs you may have a room where you have the baseband unit sitting there, and then you have fiber links connected to all these small radios going around the building. Now, there are a lot of challenges when the topology of the network changes this way. If you think about it, back in the day, I would say like 15, 20 years ago, you had a simple network, a 2G network, maybe a GSM type or CDMA type network, or even before that, there was TDMA network, where you were just, you had single link, single user kind of optimization, and to manage a network was much simpler. You had not that many carriers to deal with. Then came 3G, where your network wasn't still, from an optimization and deployment perspective, was relatively very simple. Then in 4G, when you had multiple layer of network, you have WCDMA underneath it, then you have LTE on top of it. In some cases, you still are running CDMA or EVDO network, and then came different technologies like MIMO, and you have the to further enhance that, you have COMP and all the other advancements that are coming as part of 4G. Now, this thing is not going to get any more simpler. Actually, it's going to get much more complex when you will have, CRAN and things like that in 5G. Like, what is 5G? I think the jury is still out. It will take some time to identify what true 5G means. Is it like a mesh of 4G technologies and other enhancements of small cells and what have you, or would it be a purely new, different type of air-link management? We don't know yet. It will eventually, we will figure it out in the next few years. Anyway, now based on this kind of a topology that you will see, now managing a network like that is very, very becoming relatively difficult. And operators from a cost perspective are looking at much cheaper tools. You have different type of services running. You have VoLTE, you have video, you have EMBMS. You have to manage advanced features, deploy them, and make sure they are working the way they are supposed to be. And we talked about heterogeneous network themselves. So all of these things offer a huge challenge to the customer. I would say the service provider especially, and their objective is very simple. Reduce my CapEx so I don't have to deploy way too much extra stuff and not to buy too many tools and what have you, and reduce my OpEx as well. By making it simpler and not hiring too many resources to go and optimize these networks. So they are looking for simpler methods of optimizing network, at the same time improving their customer satisfaction and quality of experience. with that, I mean, I wanted to discuss, to take one more minute just to discuss the DAS architecture. So what is a DAS? I mean, DAS, distributed antenna system. There have been passive DASs and active DASs. I mean, passive DASs were the thing of the past. Nowadays, a lot of the time, and I would say is spent on deploying active DASs. DASs have grown significantly, and we'll talk about them in a minute. But what happens that in a typical scenario, and not necessarily that's the only way, because different DAS vendors have deployed or developed different kinds of DASs, you take a signal, an RF link coming from a regular macro base station kind of a thing, take that, send it through a conditioning equipment where you drop down the signal from 43 dBm to a much lower, where then that signal is fed into the DAS head-end unit. So basically you are taking the RF energy that is coming down from a regular base station to a much lower value, convert it into an optical signal, then pass that optical signal to the remote units that you have all around the building or a venue. And then from there, you convert it back into your basically the RF signal to the antenna. So as you can see, the purpose of this picture is to show how complicated a typical DAS deployment can be. It's not just your typical just RF cable, take it to the antenna and you're done. Actually, there's a lot of testing that needs to be required. There's a lot of failure points which are added in here. There are significant benefits of DAS because macro cell cannot do what DASs can do, and especially in much larger areas, because the cost can be astronomical if you just try to do something with a macro cell. A small cell is a solution, but then again, that can be significant as well too. So depending on how much of a square footage you have to cover, depending on the type of the building, depending on what kind of leases you can get, there are multiple things that you have to consider when you have to decide whether I have to go with a DAS, a small cell, an enterprise femto, and what have you. But in any case, if you are deploying a DAS, you have to deal with fiber, coax, twisted pair, and the RF link optimization as well. So it is a very complicated and complex network by itself. That was the whole purpose of this sharing this picture. Now, in the next area, we will talk about the other challenges that we haven't talked about yet on the DAS side. So going into that, so DAS is just not that the fiber link and all that stuff. It's a very complex, I would say, ecosystem as well. A lot of partners are involved. We will talk about in the next few slides. Then you have to also consider the deployment cost, because it can vary, especially because of the different partners that are involved, the regions, where the DAS is getting deployed, how big a DAS is, and all that stuff. So venue access is also a challenge, because places which are sometimes, I would say, convention centers and whatnot, they're not just open to everybody that you can go every day and deploy a DAS and take part in it. You have to require, you need access, and access is provided during certain times. Let's say there is a game being played in basically in a big venue, so you may not have access for a few days in those scenarios because of other preparations and whatnot. So you have to manage your time as well. Service activation time, because again, it's all about your return on investment. If you delay the project because of certain complexities, then basically it becomes it is not a very valuable, or I would say the value of that solution goes down and keeps going down with time. So return on investment is the key thing, and service activation time is very, very near and dear to service providers. And of course, after you deploy it, the operational cost of the DAS has to be considered too. Basically to make sure that I will continue to offer the same level of service over the period of time when the DAS is already out there. For example, if you go to all these big casinos that are in Vegas, there are service contracts where these DASs have to perform at a certain level, and they need to be tested on a very regular basis to make sure that the same quality of service is offered. So operational cost is also one of the key things, not just from a quality of experience perspective, but how much utilities and all that stuff has to be considered as well. Next slide. So the first thing we talked about was the ecosystem. So just to give you guys a glimpse of what a DAS ecosystem really looks like. If you think about it, there are multiple parties involved. It's not just the service provider themselves, like the AT&Ts or the Verizon or the Docomos of the world, right? It's more than that. Yes, they are the big fish, and they are the folks who are going to be basically making the payments to the rest of the parties involved in this ecosystem. They're the key ones, but they're not the only one. There are multiple parties involved. For example, cable contractors who will come out and deploy these all end-to-end fibers and coax and Cat5, whatever, right? I mean, consulting firms which will help them through the whole process, educate the end users and the contractors, the building owners. In some cases, the DASs are actually built by the building owners themselves, and they are the owners, and they offer the ones the DAS is deployed working with different parties. They basically invite service providers to come and use their DAS. It depends how that model works, right? Now, DAS integrators, that can be consulting companies or contracting companies who can offer to deploy the solution. DAS equipment manufacturers, which you cannot, like, basically they are the second most, I would say, the important group of people, because they are the ones driving the technology and offering different type of technologies like the CommScopes of the world, the mobile access or TE connectivity or solid, right? Also, one of the key players in that are basically the distribution agents like Tesco, Graybar, Annexer, what have you, like people who are involved in buying different components where you can go and get different components. They are basically that, I would say, the channel partners used in most cases. Remember, DAS is not just about one piece of hardware. There's tons and tons of small stuff that is involved in there that needs to be purchased, and you have to work through the complete chain to install it. So ecosystem is, as you can see, is a very complicated piece of DAS that needs to be understood well, and which actually, in my mind, it also helps, as well as that at the same time it also creates some challenges in terms of cost and time to deploy. Now, end-to-end DAS deployment lifecycle. So if for the sake of simplicity, I've taken it from the point of benchmarking. I mean, there can be another point in my mind where you have to identify the location of the DAS by using some location intelligence algorithms, try to identify where truly there are hotspots. But assuming that we start from the point of benchmarking, it's when you have decided that this venue, I have to install a DAS because of the certain capacity demands, assuming that you have already done that homework. So what you're looking at is basically, what is the existing coverage level from the macro? So why do you do that? In order to identify if there is a coverage gaps in places, or if there is too much of an overshoot or too much of an interference that can be created in the future once you deploy DAS. So maybe I have to redesign or basically reconfigure the outside macro network. Now, after you do that, you collect all that data, you do you take it to the design tool. I mean, basically, then you start designing the DAS, you start allocating where the antenna should be going, and it's a significant task. It can be hundreds and hundreds of antennas depending on the size of the venue, what power level these antennas should be. Can I share this DAS network with another one depending on the size of the radio and what have you? All those decisions have to be made. All that data, once you design it, you have to convert it into Excel spreadsheets and what have you, and send it to your construction crew, who can take it and basically create, I would say, job request for people who can come out and commission, or basically first install and commission the cell site. So in the commissioning process, you actually turn up the eNode Bs, right, and or basically turn up the DASs and validate the DASs and eventually connect it to the eNode B. Then the optimization phase, where you want to validate what you have done is really truly offering the RF service that you wanted in the beginning. So you have to make sure your interference are minimal from the macro. You have to make sure you are meeting your link budget requirements that you originally put in there. You are getting the right throughput that you were supposed to, that you designed the network for. And then eventually it goes into the maintenance phase, where you have to continuously check the quality of your end user experience. In another way, if you look at it, the stages of that, on the right hand side, I've just shown you an example of a 2-operator DAS, a design sheet that came out once you created it. So basically, you are taking the RF from the radio link, sending it to the conditioning equipment, then sending it to the DAS head end, and then to the radios, remote radios, and to the antennas. You can see a lot of splitters and connectors and what have you are all in the middle, and you have to manage the path loss, you have to manage the link losses, you have to understand, am I within my specs that was put in the link budget? So now On the left-hand side, I've tried to map the different steps that are required, who will be doing it, and what kind of a solution you need. So if you go from the beginning, so you're doing a design and RF survey just like we talked about, right? You need an RF engineer, a tool like an IB wave, and you will need certain tools like scanners or CW transmitters to try to make sure that basically, I mean, I can capture that data and take it back to my design tool and put it in IB wave or something like an IB wave that basically you can design a DAS network. Second phase, just we talked about, is the installation, where all the design data that was created is converted into a format that can be used by the construction crew and the technicians. And then, I mean, you have to go through each and every fiber and backhaul testing, and you have to make sure that, I mean, you are starting to run the cables around the building or the venue. And the next is the commissioning phase, where we have, I mean, a lot of parties that get involved. You have multiple steps. You have to then you have to do the validation of the DAS completion. You have your project managers, construction crew, and RF engineers working together, and your construction crew and you guys, I mean, are running sweep tests, OTDR testing, PIM. You have to validate all the links, physical links that you have installed are working according to the specs. There are no additional losses because you want to make sure you get the return on your investment if everything is working properly. Otherwise, it will offer, I mean, it will not offer the same quality of experience that the network was designed for. Then you do the baseline measurements. Make sure that using your CW transmitter and a spectrum analyzer. Then from a DAS parameter normalization, CW testing, basically you want to make sure that the sensitivity of the network is there, your losses are minimized, and basically the signal that you want out there at the remote antenna is getting there, and at the head end from the on the reverse link you are getting the right signal, and the quality of the network is maintained. Once you do all of that, then you go into the RAN integration, where you hook up your RF link if that DAS requires an RF link to be connected to the conditioning equipment. In some cases, you will see there are certain DAS where there's a digital signal from the baseband unit can directly be connected to the baseband or basically the head end and converted directly into fiber. So you will not need the conditioning equipment or the basically attenuators in the middle. Once you do that, you do some pre-optimization testing, validate everything is working. You need tools like, I mean, TrueSight or tools in which you can quickly monitor the network performance on a real-time basis if you can, to improve your overall situation in which you are collecting and optimizing the network. And once you are done, you go through your acceptance phase. And of course, the product managers and project managers and RF engineers are involved in that. So this is at a high level, the DAS commissioning and optimization that you have to do and who is involved and the solution required. Now, what needs to be tested? So we talked at a high level about that. You have to test all the fiber connections. You have to make sure that OTDR testing is done, optical powers are right, fiber, I mean, all the fibers are clean. So you have to inspect it. If it is clean, good, you connect it. Otherwise, you go and clean it, and then you go back and inspect it again. You also have to do the RF coax testing, sweep testing, cables and connectors, and you can see there are a significant number of cables and connectors in there. You have to make sure PIM is extremely important, especially on the reverse link for DAS. Then you go into the system test that like we talked about. So you have to do baseline noise measurements, you have to do parameter normalization, CW testing, and noise sensitivity. Once the network goes on air, then you have to verify the signal. You have to do interference analysis, make sure there is no interference sources or PIM sources or PIM is being generated. Do antenna validation report, make sure all the antennas are transmitting and they're at the right location, right place per design. And of course, the last thing is, well, do the RF throughput. Now, let's next item on my agenda is first to share with you what is currently being done and how it can be streamlined. So going into the next slide. So in the current DAS typical process, I'm not saying that this is always the process. In some of the tier 1 operators, they have adopted a process like that to make sure that the network is delivered with extreme quality. So if you look at it, in the current DAS process, a design from the DAS design, once the design is done, it is converted into an Excel spreadsheet with tons of worksheets in it that can be used by the contractors. And then the contractors add the test cases on all the fibers and everything that needs to be run. Remember, this document is the key, sharing all the links that need to be set up, the power levels, the attenuation, and all that stuff, right? It's identified. All that information is then sent to the venue, where a project manager who is managing the whole DAS deployment works with the technician who is using basically test gears like a T-Bird for optical testing, or for something like a spectrum analyzer or a sweep test like a base station analyzer or a cable or antenna analyzer to analyze, the sweeps and perform the OTDR testing. Once all those tests are done, manually, by the way, all these steps are manual. So manually, all these things are reported back, filled in a spreadsheet. So as you can see, it's a very tedious and error-prone process. This information is then sent back to the project manager, who reviews it and everything, sends it back to the main contractor with the or the project manager at the service provider, which goes back to the engineers to analyze whether everything makes sense. And once all of those manual steps are completed, then in that case, it is considered to be the project is considered to be completed. And this thing slows down the overall process of DAS deployment. Imagine if an operator has to deploy hundreds of DAS in a year. Then in that case, for every venue, depending on the size of the venue, it can go anywhere from multiple weeks to almost, like, I've seen some cases where DASs have been going on for over a year or a year and a half, depending on how complicated the DAS was. So you can see, if these steps can be streamlined, that can significantly reduce the cost and increase the number of DASs that can be deployed. So also, we have to understand, since there's a lot of manual steps required, the process is slow and error prone, especially in some cases when engineers go out. Let's say the next phase where the integration is happening, an RF engineer goes out, then they find out, oh, I don't even know where the sweep tests are, whether these links were tested or not. And then you are flying back again, waiting for your call that, okay, once the sweeps are redone, then I will go there. So there's a lot of data that can be missed, and there's a lack of end-to-end visibility. You will have to go through a project manager to figure out if the files were delivered, testing was done, what have you. So to overcome all that, there is a solution that has been delivered by Viavi, and it's a kind of a cloud-based solution. We are using our StratusSync technology. What it does is it delivers a real-time visibility to the project activities. So once it works with the IB wave design, takes into that account, basically what you are doing here, identifying all the test cases for that venue, identifying what test needs to be run, and in real time, all your tools will be basically in that case, we basically, I would say, updated from a firmware perspective, so that everything is up to date when it comes down to the tool. And tools are directly, whenever they're in the Wi-Fi environment, they will be directly connected, and all the information will be downloaded to them, and for that project will be uploaded back as well. This offers a simple and much faster way of doing it. Think about it this way. Now, don't have to do any manual step of creating files or whatnot and sending it to one person to another. Everything is done directly, as long as people have access to the StratusSync, which anybody can have access depending on the project. The service provider can provide access to multiple parties in this, and you can then, in that case, the technician, when he or she is testing it, results are automatically getting uploaded, and everybody can see in real time how far along the project is, and they can do the scheduling right, they can do the pass fail, and all that information is already provided. So if a test fails, it also identifies that, okay, that the sweep test failed and we have to take an action. And as soon as you take the action, run the sweep again. Okay, so the sweep passed. So now we are ready. So what it does, it delivers a real-time visibility to the project, improves accuracy and reduces opportunity for errors, and reduces the risk of repeat visits to the venue to complete testing. This was one use case. Now, another use case to improve basically the deployment of DAS is on the integration and RF optimization side. So if you think about it today, and being in the field, I have observed that too, that you go and do walk tests, you upload the data. So there is it takes, like, let's say it's depending on the size of the venue. Let's say a RF engineer or a technician goes out there, walks for, let's say, 8 hours of 8 hours a day, and then after every few hours, he or she is uploading the data. That data goes to somewhere in the server. There is another engineer in the back office waiting for that data. And once the data is uploaded, they download the data. Now, if there were any issues with the data or with the testing, guess what? The engineer in the field is notified hours and may or may not get access for a few hours or days. So basically, you may have to fly an engineer back to the site again. So this whole process is very slow, in which you have to rely on the engineer collecting the data and the engineer processing the data and the amount of time it takes to upload the data, download the data, and all that stuff. So to improve that slow process, we have a solution which is a real-time analytics solution. What it offers, as the engineer is walking the venue, data in real time is getting uploaded and processed. The key KPIs, I'm not saying all the layer 3 messages, key KPIs are getting processed, and you will know right away whether, and you can look at the plots right away, whether the data that was collected was right. Am I looking if there was anything failed? Am I seeing the right throughput? Am I seeing the right RSSI? Certain KPIs are already identified on basically the plots. This helps you take immediate corrective actions, because usually the construction crew is at the site when the engineers are walking, and you can ask them to, if there is something wrong with the antenna, misplacements of an antenna or anything like that. So overall, it saves time, and it saves times for both the consulting companies, the contracting companies, as well as the service providers. If you think about it, they don't have to resend anybody there, so it reduces their cost and time as well. So just to give you a typical, I tried to do a small a kind of a return on investment type analysis. So if you take into account the amount of time it takes to do, walk test. Let's say an RF engineer technician collects the data for 8 to 12 hours. Before that, you even have to get venue access. Then you upload the data, a couple of hours usually. Back office engineers waiting there, downloading the data, a few hours for every 8 to 12 hours of data, and post-processes the data. And after that, to create the report and everything, right? Total it can range from, depending on the type of technology and the number of carriers you were testing and what have you, it can go anywhere from 4 to 16 hours. Now, once you realize that data is missing or something is wrong, now you cannot use that data to go back to your end customer, your operator, to say, I've finished it and collected it. No, now I have to go back, make changes, and retest or rewalk, right? So guess what? It can take days in some cases. To me, what happened, that if there was a venue and the game was next day, so we had to go back after a few days when the game was over. So in that time, I'm still not getting paid because I haven't delivered what I'm supposed to deliver, and at the same time, operator is not happy because the network was not launched at the time that was promised. So using this real-time process, it eliminates the need to upload, download data. It minimizes rewalks and save post-processing time. And I did a rough back-of-the-envelope analysis, and in a period of year, you can save in thousands of man-hours. One of the key things of this real-time solution is also to identify, like I said, the antenna location. It is extremely important because sometimes, and there are, cables can get swapped, antennas can be misplaced or can be loose, what have you. So working with the IB Flex solution, IB Wave, we take it into input the design file and also the geocoded design files. Using that and the RF data collected, we calculate the RF signal that is supposed to be at different locations, and thereby identifying how far off we are. We take significant number of samples. Depending on the samples, there's a confidence interval that is built in to make sure that the data makes sense. And we identify if there was an antenna issue or if there was a cable issue or anything like that. So that is also done in real time. So as you are walking, I mean, even anybody from anywhere can log in. Even the engineer who is walking can log into the network or basically into the cloud and look at the real-time data, whether it makes sense or not. And a construction crew can be engaged to fix the issue in real time. So basically, you can correct indoor antenna installation in a single visit to the location by using this solution. So like I said, the whole objective here is to improve the method in which we deploy DAS so that the time it takes to deploy and optimize DAS can significantly be reduced. The last use case I wanted to discuss is the DAS auto measure. It does two things. One is once you have deployed the DAS, you can understand that how do I manage over time that I'm getting the same results. So if you have a baseline built in, if you have a baseline data already saved somewhere in the cloud or somewhere with you, you can always compare where it was and where it is today. That's one point. The other point is, if I have deployed everything right, just a quick back of the envelope analysis can help me to identify any failure points. So this solution helps you in identifying signal degradation over time and signal degradation between 2 points. So take a reference point, antenna point, and realizing the link budget, you can identify what the pass or fail criteria would be. You can add that to the instrument, and then when you go to the reference point A or a reference point B, you can figure out how much loss was supposed to be. If it is more than what the loss should be, basically it will be marked for the end user to see whether it is out of bounds or it's within bounds. So that helps in identifying that the overall network that is deployed correctly or not, whether I'm having more loss than it should be. The second thing it helps with, that let's say you come back in 6 months and you have measured at a certain point the RF environment, and then you can go back to your reference file and compare that how far off I am. If I'm like 3 dB, you can assign the level of basically configure the level of acceptance, right? And if you come back after 6 months and you can see if it's 3 dB off or 4 dB off, or it's within the same level, right? So it helps you quickly identify any problem issues. So you can go back and say, it used to be fine, working perfect, now I have a problem, rather than going all around and trying to identify and isolate each and every problem. So you can isolate each and every antenna point separately rather than walking it and doing a deep analysis. So I think I went a little quick, but I'm almost done with my presentation if there are any questions. So Kyle, back to you.
All right, thanks, Kashif. Yeah, we've had a number of questions come in, and great presentation, by the way. But yeah, let's jump into the questions, and if anyone has any, please submit them via the control panel. So the first question, so talking about growth of the DAS market, we've been hearing a lot about, growing the DAS market. Do you think this is finally the year, 2015 and 2016?
Yeah, like we discussed, right? So DAS has been challenging from a perspective of, if you look at it from a deployment perspective, because of the cost and the skilled resources required to test it. But if you look at the data that we see in the industry right now, right, we see that DAS, distributed antenna market, hit 2 billion in 2014. And it grew about 11%. And the data I'm picking from is from Infinitics. In May, they provided these numbers, right? It's a research firm. So looking at DAS, and mostly it was done in North America and Asia Pacific. So it's not just one region that is growing, but we see that it is growing, and it is growing at a significant rate in the recent years. So we believe that in 2015 and 16 and 17, it will continue to grow. And as I pointed in my first original slide, we see that the industry expectation is to grow. With the advancement of new tools and new methods where it can be deployed much faster and relatively cheaper, we believe that it will continue to grow. There's another research firm, IGR Research. They also offered some numbers as well, and they believe that DAS deployment could see more than 300% growth by 2017. So we expect that the market will turn around. And as the deployment processes get improved and the time it takes to deploy DAS and the cost comes down for deployment, it'll be much better than what we have seen in the past. And of course, one thing we have to realize, that data demand is constantly increasing, especially in these venues where people are like, if you go to an NFL game or something like that, people are uploading data and what have you. Macro networks won't be able to sustain that. You will need some sort of an in-building network, and DAS offers the best solution compared to a small cell in that case.
Great. We have some more kind of follow-up questions to DAS deployment. So the DAS deployment market that you talked about in your slides, it shows a lot of different players with different equipment. So can the cloud solution integrate any vendor's hardware?
Yes, and yes and no, right? It depends on the party's interest, right? So the solution I was talking about is open for other different type of instruments that can be associated. I mean, currently that cloud solution already has integrated, I would say in the tens, I would say the number is in the tens for the instrument that are integrated already to that. But it really depends on how the business case works out for different companies. So the cloud solution is open, so you can bring from multiple parties the equipment, but that has to be worked between different parties, how it can be integrated. It depends on I would say, the business and the cost and the justification of it.
All right. Next question. Could you clarify why PIM is important in the reverse link for DAS?
So if you think about it this way, on the forward link, you have always got enough power. Usually, the weaker link is your reverse link, where you are very limited. If you think about from a mobile perspective, even that, right? I mean, you are talking about 23 dBm, 200 milliwatts, or something to that effect, right? And PIM usually, if you will see that. I mean, not going into the big PIM discussion, but at the same time, you will see that it does impact significantly on the reverse link, especially on the forward link. When you're transmitting at a much higher power, you have a better possibility to overcome the challenges, the RF challenges. Whereas on the reverse link, because of the sensitivity of the equipment and the mobile transmit power is very limited, so it is usually much more, has a much more negative effect.
Right, and another question about PIM. Is there a real-time solution able to identify PIM issues in the DAS and provide you with a DTF or a possible faulty component connection?
So there are different types of solution. Yes, it is possible, but it truly depends on, so there are two different things, right? I mean, if you want to talk about that PIM detection process, yes, you can do that in real time without even impacting the, if you take a macro network, for example, or any other network, right? If you can connect at the optical interface, you can put some sort of a coupler, and you can put a PIM detection equipment in the middle, so which can see as what is going on between the baseband unit and the radio. You can identify PIM related issues in real time. It is possible, but there are certain challenges. I'm not sure if across the industry everybody offers a similar solution, but PIM related challenges are there, and yes, they can be identified in real time. There are some solutions out there.
Great. Next question we had come in. What are the major differences between using coax or LAN cabling?
You're talking about depending on that also that will depend on how you have designed your network when we are talking about that, right? And it also depends on the type of DAS. So it will vary from the installation to installation. Now you will have to account for the different type of losses, and you'll have to account for different type of interfaces that are required between the remote radios. Only then, because it cannot be a very generic thing, like just like a design of a DAS will vary from building to building. Similarly, when you are designing a network and different components of a network, you will have to understand what are the link budget requirements, why I need this type of coax cable, why am I placing this radio remote unit at a certain point, and what have you. So all of these things have to be considered, And then, I mean, there's not one simple answer for that. It will vary from DAS design to DAS design.
Great. Next question coming in. Is there an impact on the network capacity because of the real-time analytics solution? Because as it seems, it is sharing the same network as the customers are using.
Excellent question, actually. I mean, just like in my presentation I mentioned, uh, the if we start sending all the layer 3 information, then it can cause a network capacity impact, but we don't. The reason is because the whole objective of the solution is to make it or simplify it from an end user perspective who is, or the customer perspective who is analyzing the data. So if I am in a busy venue and I'm doing this testing, and along with all the other real users, I start uploading this much data to somewhere in the cloud, I am going to affect the network capacity. The solution I'm talking about, we don't do that. We actually only send very kilobytes of data just from a perspective of analyzing and sending the results, which can be used by back office engineers or even the engineer in the field to identify issues. So in our solution, no, we don't have any issues like that because we are not sending significant amount of data. In fact, even if let's say the RF link breaks, for example, you're going through a bad RF coverage, the solution backs up the data or keeps the data, and as soon as you get back into a good RF environment, it starts uploading the data again, and you will see the continuity in your plots and your throughput numbers and everything. So it's not that you will lose your data, and we are not sending all the layer 3. However, that layer information is sitting there is still in the collection tool at the venue, and if somebody wants to do a deep dive or detailed analysis, they can still go back and do that.
Okay, great. We had a really interesting question come in. So, is there a prediction as to the future split between the growth of neutral host DAS and operator-owned DAS?
That is more of a financial question, I would say, than anything, right? Because neutral host, for example, I've seen multiple venues where myself that there are a lot of neutral hosts who are deploying it, and there are some places, and it also depends on which region you are talking about. For example, and I'm not going to say these are like absolute numbers, right? I mean, there are places that I've seen where most of the DAS deployment is done by the operators. And then there are regions where neutral hosts are the key drivers, and they are deploying these DAS, allocating a certain percentage of the power of the DAS for different operators. And depending on the cost model, they are deciding how many operators will be coming in and who will be getting the priority. So I think it's more of a financial question and also the time to market. For example, somebody may have already have access to the venue. So I think in some cases there is a race going on where these neutral hosts are trying to reach out to these major venues and locations and trying to get access before anybody else. In some cases, it may not be from a cost perspective viable for operators to go and deploy the DAS by themselves, because working with a neutral host will be relatively cheaper in those cases where you have multiple service providers on the same DAS. So is there like which will grow more? It will truly depend on the cost structure, time to launch a network, and all those different other conditions which are outside the I would say the technology aspect of it.
All right. Another kind of forward-looking question is, do you think the DAS market will shrink due to small cells and enterprise solutions?
That question has been asked multiple times in multiple forums, and what I mean, basically, what I believe and we believe is realize that it truly depends on the size of the venue, and again, it is more of a business decision than anything. What I've seen for smaller regions, like for anything greater than 10,000 square feet, I would say DAS has a much better chance. As the square footage of the venue becomes larger, the possibility of having DAS is more significant because the viability and the cost effectiveness of DAS improves. The smaller the building, then in that case, you are not going to deploy a DAS, and basically put a whole head end and you will have all these remote radios and fiber and all that stuff. You're not going to do that. It'll be more viable when you have a much more significant or larger venue. And again, the numbers that I've seen, that somewhere from 10,000 square feet to 50,000 square feet or more is where DAS becomes much more of a viable business case, has a much more viable business case versus in a much smaller square footage. So small cells will continue to grow, and I believe they will continue to grow at a much significant pace compared to DAS, just because of the cost of deployment of DAS and the amount of effort it takes to deploy a DAS. Whereas in the case of small cell, it will be limited. You cannot deploy small cells to that scale in those larger venues. So I think both of them will coexist and both will continue to grow. However, small cells will grow at, I believe, in a much faster rate because number one, their simplicity compared to DAS, and at the same time, their cost is lower and the square footage they offer is much lower as well.
All right. Next question we have one of the attendees seeking your opinion on the cost savings one might achieve with the cloud-based analytics you suggest, such as the big cost factor for OEM equipment. How do you see the cost component in the future?
So from a cloud perspective, the way I see that, if you think about it this way, I mean, it will be very simple to run a business case. If you think about it, how many people are involved in the discussion. What I have seen, you can see that there are people at the venue. You have a venue, especially in an ecosystem where venue owners are actually the DAS providers. If you think about that, then you have a service provider, then you have multiple service providers actually, consultants and contractors and everybody working together. Now the question is, how do I make sure that they are, using the same type of equipment? Usually what happens that I've seen, that service providers take the initiative, they define what kind of equipment needs to be used. Once that is decided, then in that case, a cloud-based solution which can basically streamline the whole process. So think about it this way. If every person, like a consulting guy who's coming out, the service provider who is coming out to the site, the contractor who is coming out, and the construction crew that is coming out, all of these people, if they are connected to the same cloud, the amount of savings will be significant. Especially now, you do not have to do all those manual tasks, and basically you won't be losing the data at any point in time. The data will always be there in the cloud, and you can access it even after 6 months. In one scenario, I saw one customer was looking at the sweep test and was trying to figure out whether the sweep tests were done, the fiber testing was done, just 6 months after, and they couldn't find out who did the test, and that company was out of business or something like that, so they were not even able to locate the file, so they had to go back and send somebody again. So think about the cost that they have to take the second time for running the same type of test. So you can avoid, basically eliminate all those additional costs of validating and maintaining your DAS and also deploying your DAS. So this cloud-based solution, in my mind, it truly offers great value and reduces the overall DAS cost, especially the deployment piece of it, significantly.
All right, looks like we have time for just a few more questions here. So next one coming in, what happens to the reports and KPIs when RF link degrades significantly?
Exactly. So that's what I was just mentioning, right? So even when the RF link degrades, the data is still safe with the engineer or the technician walking the venue. As soon as the engineer gets back into the good RF environment and the connectivity is there, data starts uploading from the same point. So we do not lose those KPIs or reports. You will not see the gap. You may see poor coverage points, but you will not see in your plots, but you will not see missing data. The whole objective is that we should not have missing data there. So through this solution, what we are doing, we will be keeping the data on the local machine. Basically, it can be a TrueSight tablet or a receiver solution that you may have, or the phones, right? And once you get back into the good RF environment, data starts getting processed from that point, and you will start your continuity on the cloud-based data that you will be seeing at the reports and KPIs will still be maintained.
Okay. Next question coming in. So passive DAS versus active DAS. Which one is more cost effective to deploy?
Of course, passive has very little amount of components in there. It's just more than likely it's a leaky coax, but they are not like the best solution. People are moving away from passive DAS. Actually, passive DASs were hugely deployed especially in the Asian markets. But recently, if you look at it, I mean, people are moving towards active because your return on investment is much more significant. Especially, they are mostly from a technology point of view. I mean, they can be upgraded easily and all that stuff, and you have a better control of your network rather than having just a leaky coax type solution.
Okay, and looks like we have time for just one more question. So DAS versus small cell, which one has better ROI within the next 3 years?
I think to me the question should be asked at the point when a network is being deployed or a small cell business case is being considered. Like I said, it will truly depend on the size of the venue. It will not depend on whether for example, if it's a small two-story building where there's a coverage issue, you're not going to go and deploy a DAS there. It has to be some sort of a small cell. It can be a femto, it can be a Wi-Fi, it can be anything, or it can be just an OEM or NEM, basically network equipment manufacturer, a small cell, right? I mean, those will be much better solution than thinking about even a DAS, right? However, if it's a significant building, let's say you are talking about, I mean, a 50-story building, about somewhere around 100 or so thousand square feet. Now, if you go back and have to deploy each and every a small cell connected to a cloud RAN somewhere, or like a big hotel or baseband unit, that will be much more significant. Now you'll have to do an analysis, and most of the time you will see the reason DAS might win because it is mostly from a technology point of view, it is very agnostic. It can offer multiple operators very quickly. I mean, so basically the cost can be shared and all those things. So you will have to do a business case depending on the size of the venue. It's not just done with respect to like you're gonna do just an apples to apple comparison. To me, they are playing in a different field, and at the same time, you have to understand the benefits of DAS versus the small cell.
All right, great answer and great presentation. That's about all the time we have for today's webinar, Streamlined Deployment Approaches to Improve DAS ROI, presented by Viavi Solutions. Again, our presenter today was Kashif Hussain, Wireless Solution Marketing Manager at Viavi Solutions. Thank you, Kashif.
Thank you.